The topic for this workshop is about mocking AWS services with Testcontainers, WireMock and Localstack. One thing I wanted to do double check with the audience, does everyone use Java or do you prefer another technology stack? Okay, today I plan to focus on Java, and basically Java is one of the most established language ecosystems, and it means that you can do pretty much everything in Java that is related to platform engineering. Yeah, you can write your application, integration tests, you can define builds with Java, or for example, if you use Gradle Kotlin DSL, and you can do a lot. What you can also do is actually implement deployment pipelines with Java, deployment tests sometimes, and even production health checks. There are tools for that. The question is, of course, whether you need it for everything. Maybe the answer is no. But the point for today is that you can. And I actually plan to start from the first parts. I do not think we will ever get to monitoring. I actually don't even have slides for that, but if you want, I can share some tips. So what I wanted to do today is basically do some introductions for tools, depending on whether it's needed, but then discuss modeling AWS services specifically. There is no miracle. We will be using Localstack for that, with Testcontainers, with WireMock, and with other tools. And then, of course, we will talk a little bit about building your own developer environments, and yeah, using infrastructure as code to actually manage deployments and how you can test deployments. Does it match your expectations? For me, the first question that I actually want to ask in any case is what is your experience? We will get there. One thing to mention, my slides are already public. You can actually find a lot of auxiliary tutorials on my speaker deck, but I'm going to just drop the slide deck in the chat when I find it on the screen, because there you can actually chat. Seriously? I had a chat and now it's gone. Okay. Just a second. It should be actually still available in Zoom. I was locked out from Zoom. Okay, it explains quite a lot of things. I'm not sure why it happens now. But I definitely need to find a window where I can fix it. Okay. So basically, my slides are there. I don't plan to spend too much time on the slide deck. We can go back and forth depending on the interest, depending on the questions. I will later publish it on my speaker deck, so you can find a lot of information there. And yes, we've already spent quite a lot of time on the opening. I will just do quick introduction, actually dive into the top. Okay, so I work at Gradle. I do quite a lot of developer tools contributions. I started my open source career with Jenkins, then switched more and more towards integration testing. I contribute to Testcontainers, WireMock, and there is a lot of other tools that I use and like, including Localstack. And today, again, I'm just presenting specifically on AWS. If you want to ask anything, we will have some time after the workshop. One thing I always want to highlight, we're doing a conference in Geneva in December, and there is call for paper opening soon. So if you have any platform engineering or community stories, it's one of the conferences to consider. Okay, and another disclaimer that is always needed when I touch Java and Gradle is what Gradle is. Because there is Gradle as a company, Gradle Inc., and actually we work on quite a few projects. The project I will be using today is Gradle Build Tool. It's open source project, which is normally called as Gradle. It's what you build your software with. We also have Velocity, it's commercial platform for all kinds of developer experience things like build caching, test parallelization, predictive test selection, flaky test detection, etc., etc. So we will probably touch it a bit if something breaks, but that's it. And we also do a lot of things around developer tooling and productivity engineering in general. So this is why these talks are quite interesting to us. So Gradle build tool, I hope everyone uses it, or at least saw it. It's open source. We have, of course, all the information and documentation available here. If you don't use Gradle, don't worry. It won't impact you too much during this webinar. Well, it's not webinar, it's workshop. And yeah, if you use Gradle, consider trying out release candidate for 9.0, which was shipped a few days ago. Okay, so why I'm doing this talk and why it actually matters. For a long time, we were doing tests and integration tests separately, and most of developers didn't really like integration tests. But these days, with modern tools we are talking about today, actually it becomes the same as common testing. Moreover, staging environments, developer environments, test environments, they're also going away. So the pipeline becomes quite simple. That's great. At the same time, developers become responsible for the whole bits of this pipeline. Many companies haven't seen quality engineers, let's say, for the last 5 years, because now it's developer teams with enabled DevOps so that compile all the quality assurance roles. And that's how it goes. What I wanted to check with you, we do not actually have so many people on the call. I'm not sure whether it makes sense to do Slido polls, etc., but maybe I should do. So let's do it actually differently. So we have a number of tools today. Is there anyone who has no experience with these tools and who needs an introduction? So I saw there was one comment in the chat that from Scott that he doesn't use Java, mostly Python, Gradle. Then there is Node.js, Python from Brian. So I assume not everyone does the same toolchain. One thing to mention is that, okay, so we will definitely need to do a quick intro. One thing to mention that all app present can actually be ported to other platforms because Testcontainers and WireMock, this is foundation of my talk, both of them are available on different technology stacks. And for example, if you go to my speaker deck, you can find that, for example, there is presentation for Golang. Wait, is yeah, Testcontainers for your Golang projects. I also did a quick presentation at PlatformCon. I'm not sure whether it's already live, but basically this is the same technology stack we are talking about today, and you can follow it. Same for Python. So for Python, yeah, it has been a while, but I also did a presentation on Python toolchain with Testcontainers and WireMock. It's for data mocking, but you can apply the same knowledge we are going to get today for different technology stacks. So if you don't like Java, if you don't use Java, please bear with me. And yeah, based on feedback, I will still do some introduction for tools. So most like we will spend some time on the introduction specifically for Testcontainers and WireMock, and all this experience is completely portable. Okay. Okay. There won't be much YAML in this presentation, by the way. So I'm actually going to focus specifically on Java. Okay, so what we are using today, I have a GitHub repository that has all the information needed, and actually it has all the demos I will be showing today. So we will start, I think, from the beginning and go like that. You can see that there is a red cross, so it means that something is likely to go wrong during the presentation. Let's see. Yeah, all the code is here, and supposedly all the code is working. One thing to double check, does anyone want to follow along during the workshop, or basically should I follow the show and tell approach? I will be showing particular bits, discussing it without actually giving you tasks. It's one approach, and another approach, we can reach particular stage, for example, Testcontainers, and try writing tests together. What would you prefer?
I think you'll have to install all the tools. It might take longer, so it'll be good to kind of just follow you
Mm-hmm.
as you do things.
Okay. Then just let's try this quick show and tell for the first part, and then let's see how it goes. Um, okay. Mm. Yeah, so what you technically need if you want to follow this workshop, you need Java 21 installed on your machine. You can use Java 17, but yeah, the project is tested on 21. Then you need test containers compatible Docker environment. For example, if you use Docker test, is way enough, whether you use it on macOS or on Windows. If we reach configuration management part, so then you will need Pulumi and your build scan account would be nice to have, but it's not something we will be spending too much with specifically this presentation. So let me just do a quick introduction to tools then, and then we will switch to the code. So yeah, as I mentioned, there is less people actually doing integration tests separately, and what it means that it mostly becomes a part of developer responsibility to create proper integration tests. And there are frameworks that are supposed to help with, so maybe it should be easy. The problem is that all these frameworks, they are always difficult to manage. They may be quite complicated. If you go to container environments, that it becomes even more difficult to orchestrate resource usages, etc. So even with modern frameworks, basically your experience depends on you and how you organize your internal frameworks to do the bits. So what companies normally do, they take building blocks. For example, if you need to do integration testing, you can take test containers to provision the service. Then you need models for your particular services like AWS and Localstack, and you combine everything and then create a test framework on the top of it, which can include, for example, new API libraries so that you can write tests easier, or it can have some pipeline templates, whether you use Jenkins, whether you use GitHub Actions. You have a way to actually unify execution of tests, of build pipelines, and reduce these parts. So you build a framework that actually hides all the complexity and provides a better developer experience. So there are multiple ways to approach it when we come to integration tests. And there's ancient way, creating staging environments, test environments for testing. It's quite good in terms of accuracy. You have real system, but then you need a few people or maybe a team to maintain these staging environments. You always have issues with versioning there, with consistency, cleaning up the things. So for many, it's not something they do anymore. On the other hand, you can just use mocking on the cat level. Whether you use Golang, Python, or Java, you can do some instrumentation for your code to isolate particular bits. So for example, in Java, there are frameworks like Makita that allows you to replace a particular function call by another code. Good advantage for that it's really fast. At the same time, basically modifies your application. You don't do test integrations. You don't test your network stack, and it might be quite difficult to maintain, especially in the case of Java, where you have such funny things like bytecode modification to inject test frameworks. So all of that becomes really difficult when you migrate between the versions. So it's not something I recommend. There are two approaches in the middle. One of this is basically just spinning a model of your system in a container. And for that, I recommend test containers. So the idea is that you take a simplified version of your system, and this simplified version of your system provisions specifically for your test execution, and you start using it. And another one is basically mocking or modeling this application. So when you don't have an implementation, you could put in the container, or whether this implementation just doesn't exist, then you can take the specification and build a model that would execute some bits and provide you with results. So options 2 and 3, that is what we are normally doing. And sometimes I will be mixing mocks and models. So for me, models is what really represents business logic and behaves as a service, though it's still a simplified version. And mocks is basically just a stub based on the behavior without too many details. Um, if we talk about AWS, and today, of course, we are talking about AWS all the time, but one thing I'm going to say that it's the only time I'm opening this page. I'm not opening even AWS console, etc. So everything we are doing today will be local with the help of the tools. And the first tool that I always use if I need to touch AWS is Localstack. So do you need intro? Okay, just a quick one then. So the idea is quite simple. A local stack basically implements emulation of AWS within your local environment or within an external system so that you can actually write and test your application. So in principle, it's really easy to use. So you have an application that basically does all the execution. So here, if you go to a local stack site, you can see that there are basically just a download that you can take. They all say that integrations for Snowflake quite recently. But the idea is simple. It's a service that implements execution. So you can provision local stack on your port, and then basically it runs, for example, here as 3 buckets with some security model if you need to test it, with some integrations if you need to test it. So it's basically a simplification right on your machine. The problem with AWS that it's just infinite ecosystem of so many products and services, and of course there is nobody that can fully implement them properly, and obviously there is not that many people who would do it for free. What it means that some services they're actually emulated. So for example, if you have S3 SQS, you can get a kind of real alike behavior within your local system. Um, at the same time, if you have, let's say, EC2, EKS, etc., then it's much more complex system and you just cannot run it locally, or it's super complicated. For that, there are 2 ways. Firstly, Localstack has a commercial offering that actually provides some hosting and implementations for more advanced things. Or you can just use mocks that implement very basic behavior. Still, there are some services that do not exist. Well, OpenShift is just an example. It's from the meme from 2020s or so. But yeah, that's actually one of the ideas of using the smokes so that you do not really have to pay for real AWS for most of your integration tests, which is something nobody likes. There is a question from VJ. Is Localstack AWS specific implementation or can you emulate other cloud providers as well? So it's complicated, but yeah, there are multiple implementations. Not here. Okay, so we can just take a look here, and here you have an answer. There is local stack for AWS, there is local stack for Snowflake. If you need a local stack emulation for GCP, what you can do, you can search for similar applications and you can actually find some. So for example, here there is implementation for GCP storage. There are some products that actually try to combine it and provide similar offerings. But yeah, I wouldn't say that there is something as so integrated as it's available for AWS. So if you're using Azure, if you're using GCP, you will need to collect these services from different sources. And later I'm going to show, for example, WireMock or Testcontainers that actually does some bits of that. So for example, WireMock, it's just a heads up. Oops. Yeah. Okay, so here, for example, if we go and look, ah, there is no longer search on this side. Okay, yeah, there is cloud. And here you can see that basically there are models and mocks for particular services. So, for example, if you use Microsoft, etc., you can check this site, and pretty much the same, for example, for GCP, they should be also here. That actually allows you to replace particular services APIs when the implementations like Localstack do not exist. Another approach, we will just reach it in a few seconds, it's Testcontainers. Okay, so I can show you a really quick example of how really using AWS looks like. Just a second. I probably need an ID. So this here in a local stack application, we will get to it get back to it later, but just to show how it look like. So there is a test based on Spring Boot, and here we also use Testcontainers implementation. But the approach is simple. Here we say that we need a local stack. So it's supplied as a Docker image in our case. So all the implementation will be running in a single container. We configure the service. So here registry is basically a configuration of our Spring Boot application. So when we start the test, we override configuration to use the test service we provisioned here. And then we basically just start consuming into our test. So this implementation, if I recall, yeah, it has SQS, it has S3, and it also has some credentials because everyone needs them. And the test is very simple. It will just send a message and see whether it will actually reach the S3. Because in our configuration, it should be actually reaching S3 in the integration test when we send it over SQS. This is what this application does. And this test basically tests it. And the advantage is that you can run this test locally. So I'm doing it. There is no magic. I don't even have AWS keys configured on this machine. So if I was using something, we would have known about it already. Okay, test passed. So basically, this is very quick example of where we are going to get maybe in 30 minutes or so with all the tools I mentioned. And yeah, you can see that something is going wrong because it cannot execute the request, maybe because of the provisioning, because here it takes time for everything to provision, but then eventually it completes and everything is provisioned. So, do you still see my slides? I guess not. And I definitely do not see the button again. Oh, what I can do, I can actually just share two screens, but yeah, we will return to it later. Okay, any questions so far? Okay. Yeah, then let's just get to this implementation. So Testcontainers. Yeah, as I said, not everyone uses it. So Testcontainers is basically a project that started about 10 years ago, firstly as a Java implementation, and then there are many other implementations that were added. And the idea is quite simple. It's a framework that wraps unit tests and provides you with an opportunity to provision custom environments to run the tests. So it was created by many contributors. Then there was a company called Atomic Jar that implemented quite a lot of solutions, including Testcontainers desktop. This company was acquired by Docker. So now Testcontainers as a project is a part of Docker. There is a lot of external contributors like me, and yeah, there is quite a big ecosystem. So started with Java. It got a lot of adoption, and now it's available, for example, for Python, for Golang. I'm a maintainer of test containers for C, C++ implementation, just in case anyone uses it. And there is quite a lot of tools available. So the principle for test containers is quite simple. In your test, regardless of the language, you can say that I need a particular container and then just start using it. So for example, in Python, in Rust, or Haskell, you have this opportunity within your test or within your test framework, just to provision a particular container. It's not just provisioning, because test containers actually resolves a lot of things that are normally required as a part of framework integration. So for example, it can, of course, deprovision container, manage resources, it can suspend containers, so you can reuse it. So performance-wise and technology-wise, there is quite a lot of bits available. And test containers provides you with SDK that allows you to test particular services. And you can overwrite this SDK if you need something. So for example, there is a marketplace for with particular models. If we go to Java, you can see that there is a lot of things available, like, for example, databases, or if somebody asked about Asia. So here you can actually model particular Asia applications just using test containers models. So the idea for these models is that they provide not just implementation. So if you use Cosmos DB, so let's see what they have in the documentation. So basically, you can provision a container that you consume, and then you can basically start using this container, configure it, etc. And all of that is integrated as a part of your framework. So when you use a language, you basically configure the service and reuse it later. Also, some implementations have special APIs for integration testing, for example, assertions, like, for example, for S3 bucket, whether the data was actually stored there. So it simplifies writing the tests, because test containers basically implements an end-to-end solution. You do not just run something, you reuse the thing. Let me show you a more practical example in my repository. So it's actually integration tests we use for WireMock. So there is a Docker image, and in my project, I need to test how these Docker images behave. So here, it's a Gradle project, but basically what I do, I take test containers. I also add some additional models. So for example, here I'm using Localstack for some cases. And I think I don't really depend on most of this in this particular project. Yeah. And if you need Java implementation, it's also here. So, sorry, Maven POM implementation. So you can basically choose what you want, and then you just write a test using this framework. So a very basic smoke test would be, for example, here. So you take, it's a JUnit 4, I think. No, it's JUnit 5 implementation. So here you say that I run my test with test containers. And then basically you just, you don't see my IDE, right? Or do you?
Yes, Testcontainers Azure.
No, it should be in IDE already.
We see your browser.
Okay.
We see ID now.
Yep.
So, okay. So does it work now? Okay, let's go back a bit. So there is test containers demo in the repository. In this demo, I can set dependencies. So here I basically consume the test containers model, and basically I use just definitions that I would like to consume. And this test does very simple thing. There is a Docker image, WireMock Docker, that we can consume or provision particular tools, and I want to write a smoke test. So here I say that in my test I would be using test containers, and I define a container. So here I say that I want a WireMock container. It's a model provided by test containers, and I configure it. So there are some mappings for requests, responses. So these mappings should be here. Yeah, so for example here, so hello world. So basically this mapping just receives a hello request and responds with 200. It's one of the basic functionality of WireMock as a tool handling requests responses. And in my test, basically I say that I need this WireMock server and then just write the test I need. So I rely on Testcontainers as a framework to provision the container itself, to manage its availability, to map it to the proper ports. So none of that is actually my business, and I just run the test. And this test, yeah, doesn't load, which reasons unknown. It's a Gradle project, so yes, it won't load here because it mapped to the main definition. So, but basically, we just implement a client or we launch our client application and say that we need a particular bit to actually um, well, we send a particular request, we wait for the request to be processed so that it fails if something is wrong. And then we basically wait for the response and process the response and ensure that this is correct. Of course, it's not all you can do. Let me just show a more complex example. I'm just going to load this project as Maven because, yeah, otherwise it won't actually allow you to execute the tests from IDE. Okay, so this is basically the example we looked at, and here, yeah, we start execution, and just in a few seconds it should complete. So it's 4 seconds, but yeah, it's just a clean startup. And here you can see that basically container was provisioned and our application connected to this service and did the execution. Of course, it's a very boring example, hello world, but we can do something way better. For example, WireMock, there is an opportunity to send a callback webhook, and we can also test it with the help of you still do not see my ID, right? Okay. Yeah, sorry. Wait. Okay. Do you see it now? So
Yeah, we see your ID.
yeah, sorry. I didn't plan for Zoom, so there is a bunch of inconvenience here. So if you see that basically my screen feed goes out, we don't have a host. So if I miss something, please let me know. So here, yeah, if you run a test, this test yeah, completes. Now it's not 4 seconds like it was. Now it's just 2 seconds because we got a few caches enabled. But yeah, you can see that there is container provisioned and we get quite a lot of bits. And yeah, what this test executes, there is just a container that does quite a few bits. More advanced use case is here. It's for webhooks. So you can configure WireMock to send a webhook. We are not touching WireMock specifics yet, but this is just an example. When receiving a particular request, it will actually send a webhook and include some information there so that we can ensure that this webhook is from this service. So if we need to test our service that sends webhooks, what you can do with Testcontainers is basically the same. We provision it, and we can create more complex synchronous logic like here. So here we say that wait is and it still didn't load here. Okay. Yeah. So in this test, we basically send a request, and we can expect some asynchronous responses. So you can see that the logic is a little bit more complicated. Obviously, if you use a framework like Rest Assured, etc., it becomes more simple to define these tests. But yeah, this is a kind of raw Java example. So this is what Testcontainers is in principle. Of course, it has a lot of advanced features. So Yeah, let me switch to the browser. So what you can do with test containers, for example, is Docker Compose. If you just need not a single container in your integration, but multiple containers, you can provision a Docker Compose file that again implements whole your system, whether it's system on the test, whether it's a database and other components, and it can be transparently provisioned by test containers and then managed by it, and you can just access it with the tests. Test containers itself, you can see that there is a lot of documentation like for any other tools I mentioned today, because there is a lot of advanced features. One thing to always keep in mind is that containers might be actually quite slow. So test containers has a lot of capabilities to improve this behavior. Of course, it has various wait strategies to verify the completion and initialization of your service. So it's not like you have to implement your own scripts to ensure that tests behave correctly. Many models provision these endpoints so that you can correctly verify the services. And also you can reuse containers. So there are multiple ways to reuse a container within your test suite. One, you can provision test containers only once. For example, in Java, you can use class rule to say that the whole test suite uses the same test container, so you don't have to provision it. And you can also suspend executions. So for example, you had a database, let's say Oracle database or just emulation of AWS something, and it takes a lot of time to provision it. But with test containers, what you can say that basically I will be using the same database for all my usages. We reuse it, and then basically this container will be reprovisioned within tests and suspended when you do not need it. So you can get the startup time for particular test to milliseconds. And all of that is a part of framework, so you don't have to worry. And you can write quite complex implementations. So if you want, there is a lot of test containers, demos, and examples around here. So in my case, yeah, what I can, well, we will get to a few examples later. But basically, what I presented is available in the workshop repository. And also, for example, if you use Quarkus, etc., there are different ways to provision these containers that integrate with framework beta. So far, we just took a look at a very simple JUnit implementation, so that it's quite native to the Java framework. Okay, any questions so far? Okay. So yeah, we can skip this part completely. One thing specifically about local stack is that, of course, it becomes a little bit more complicated to use it, and there are multiple ways to provision local stack implementations. I will switch back to IDE to show some real provisioning of local stack. Wait, this. Mm. Okay, so okay, so let's take a look at a more practical application. So one that actually uses local stack. So this application is basically what I presented before. So it's what takes the application. It is basically a very basic Spring Boot application. And what happens here that basically on receiving the messages, it should basically detect a bucket and upload this message to the bucket. So basically it's just a common SQS implementation. And you can see that it uses definition from SQS, listener, etc. So it's basically native integrations of Spring Boot. What is? Yeah, you can see that it's AWS Spring, so special library for connecting bits. And in the test, Again, this test basically uses just test containers and WireMock. So now, after going a bit to test containers, you can see basically that it's Spring Boot test. Again, it uses the same annotation, the same container provisioning, and just ties one bit to another. So after that, it becomes basically quite easy to do the execution. So here, if you launch this test, so it uses local stack image. You can see that basically local stack is provisioned in Docker. And yeah, here, well, there is nothing interesting in test outputs. It's actually good when test completes. And yeah, here are details. So you can see that basically just does the execution, provisions the environment. So here, yeah, local stack, host environment is completed. Then we have Spring Boot, and yeah, all the execution happens, and you can see that the test itself takes just 2 seconds, even if we provisioned S3 and SQS locally. And these models, so they actually do something. So this is how the code could look like, and you can see that this is still a very, very simple implementation. You can add more. One thing is how to actually use test containers and other bits, because this definition that works great when we have the implementation. As we touched, there is basically not so many implementations available beyond what local stack provides. So for Asia, etc., you don't have this luxury. And you still need to somehow actually mock or model particular services that would be needed for your execution. One of the easiest solutions to do that is using a tool like WireMock or Microx that actually provides the implementation upon demand. So who's familiar with WireMock already? Okay, so very basic principle for WireMock is that it's a service that actually mocks execution. So it acts as a server that receives your requests and provides responses depending on some configuration. Of course, there is devil in details because there is a lot of advanced features that are available that makes it different, makes it matter. Otherwise, it would have been a really simple service. So the idea for tools, well, actually there are many tools available on the market. I normally use either Microx or WireMock, so this demo is totally for WireMock, but if you want, we can actually do more. There is a lot of advanced features. You can do conditional request matching. I've already quickly presented it, the webhooks. You can template the responses. You can just inject failures. For example, if you have a test that doesn't fail, a test for the application that doesn't fail. It's actually quite good when you have a stable service, but when you properly adopt DevOps, when you have microservices, it becomes extremely difficult to fail the services. And this is actually where WireMock can help, because it has a capability of simulating faults. I'm just showing some items from the documentation, and here you can see that, for example, you can inject a delay if you want, or you can basically just make gibberish data. You can inject a particular failure, like failure responses, different error codes, and all of that can be done based on particular parameters. So WireMock supports request matching. So you can easily write that, for example, for particular request, like for example, here I pass tool, which equals WireMock, you have different behavior. So I can inject failure for particular configurations that again can mimic complex scenarios. Also, there is stateful behavior, ability to proxy and record the things, to basically record the interaction sequences. So the complexity of a tool like WireMock goes well beyond just request response. And of course, it supports different technology stacks. So again, if you use Python, Golang, there are implementations for that. And one of the, well, for Java, where WireMock started, there is quite a lot of things. There are bindings for particular languages. So for example, when you write code in Kotlin, there is Kotlin DSL for that. If you develop with Quarkus or Spring Boot, there are frameworks that actually do mapping and simplify usage of the configuration. And yeah, same for other tools. So for example, if you want to do WireMock for Golang, yeah, it's also quite straightforward. There is a WireMock model, so WireMock Testcontainers Go. And basically in this model, I have a GIF of the demo. It's more simple probably. So this is just how it executes, and also it's about seconds with Golang, with other systems. So this tool is as portable as test containers, and they actually work in combination so that you can build your test environments for different configurations. So for build tools too, for Gradle, or for example, for CI systems like Jenkins and GitHub Actions, so there are also some integrations that actually provide ecosystem on the execution level. Whether you need it or not, it's a completely different story, but I'm just saying that it's available. So this is an example actually presented a while back. So we are returning to the initial topic of this session, and you can see that WireMock and test containers can be provisioned together, and they work quite well. So I wanted the switching to IDE at this point, but what we passed through in terms of introduction is actually test containers, API mock, and local stack. And I can show you a more practical application of how these tools work together, for example, with Spring Boot. One thing I wanted to check before that, so does everyone already use dev containers? So it's basically dev containers. It's an opportunity to provision your developer environment within your IDE. So for example, if you need a service, if you need a database, or if you need a particular built environment, you can provision it, and it's quite popular for Visual Studio Code. So I can, for example, open something I worked on recently. Wait, is. Mm-hmm. 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 Yeah, I should have just shared on my screen in the beginning, but yeah, on a bigger screen, it becomes quite complicated to manage. And with okay, so it's basically Visual Studio Code. It's one of Gradle's project, Gradle Cookbook, and there basically it uses mkdocs. It's a documentation site, so it means that you need Python environment, you need some configurations, you need some plugin dependencies. And yeah, there is, for example, a list of requirements that would be consumed by this particular project. So you can see that this environment might be a little bit difficult to manage, especially since some of the services also have native bindings and other things. So this is why I prefer Java to Python sometimes. And what you can do with test containers or with dev containers is actually provisioning it right inside container. So you can see that I'm opening the environment. I don't even have Python on my machine, but here I can, for example, connect and build my service. So that basically I get the environment that is fully controlled, that uses, for example, this Docker file. Well, you can see that it's classic Python image with some native packages, and I have everything built. I can also do testing if needed. So, for example, here, if I open it in new tab, you can see that actually it's no magic. So it provisions my configuration. It's a very simple documentation site that has a lot of things, but actually I develop it locally. So this is what many people already use to develop these different environment stacks, because it's super difficult to manage everything on a single machine. Things break. And there is an idea of having the same for your developer environment. So instead of having local developer environment, for actually software development, not for integration tests, you may want to have the same auto provisioning. Um, there were a lot of tools for that. The first thing that has been really successful is Quarkus Dev Services. So basically, it's a service. Well, Quarkus is one of Java frameworks, and it also has different tools supported. So if you develop locally, for example, with Kubernetes, or again, if you need Elasticsearch or other services, you can provision the tools on demand and they become available. Also, there are mocking tools like WireMock and Microx available here. And actually, many of these services run inside dev containers. So the idea for these tools that they become basically make your developer environment transparent to the application. And the best example again is for Quarkus, I think, not for Spring Boot. We will get there. And for Quarkus, for example, in this application, you can say that, for example, I have an application here, and in my application configuration, I just say that I will have different environments. And here I say that, for example, a production service will go for production implementation. I will go to real service provider. It's Hacker News Lister. And for dev and test environments, I will actually use a local mock. And then using various configurations of the service, etc., I can reuse this service inside my local definition. So this is how it can be defined. And for Quarkus, it works quite well. For Spring, it works a little bit less well, but it also works. And more importantly, all the things become completely transparent to your application. So, for example, this application, the source Hacker News, you can see that I actually just retrieve data from the service when needed. But if it's not needed, I will use common implementation that just goes to the real service. And it becomes totally transparent to my application. So I can write, I can develop the things locally without actually caring from where the service comes from. So this was idea for Quarkus Dev Services, and it's also available in Spring Boot these days. So there is Spring Boot Dev Service, which basically goes it further. Well, takes it further. It takes Testcontainers, WireMock, and other tools, and basically provides them in developer environment. So you don't need to use it just for tests, but you can also use it for developing your applications in real time. So in Spring Boot, well, it's basically the same. You define some ports, some dependencies, and everything works transparently. So let me show it, for example, for the project demo I had. It's Spring Boot. Okay, are you still with me?
Yep.
Okay, so this is again our repository, and there is this local stack application. No, this one, API mocking. So API mocking, again, it uses Spring Boot application. This one doesn't rely on a AWS service, but you can connect it. Here I used PostgreSQL as a database. And I just say that I need a Spring Boot Docker Compose, which will automatically provision the environment for me when I execute the test. And there is no magic for this environment. So Spring Boot implementation is much more simple than than Quarkus one. It goes to Docker Compose file and says, I need a database for particular version. If I want to use Localstack, again, here can be a Localstack image with all the configuration so that you can reuse it. And then basically, again, in the test, in the developer environment, you can just start using this bit without caring from where it comes. So I don't have local PostgreSQL implementation, and this service will be actually using what I have locally. So let's just try to do it. Well, unless I broke something already. So it's basically okay. I don't have CLI completion here. Do you see it now? So it's basically test container, thanks containers and Spring Boot based project. And here we use boot run. It's just a command for provision particular application. And let's see whether it works or not. So here you can see that basically there is provisioning, and we can see that basically it initializes Spring Boot application. It also looks for test containers, provisions then, and then I think we can just go to our browser and see whether it operates in, whether it really operates or maybe not. Okay. Okay, yeah, we got this application. So we still need to have some backend because we will be connecting back to the database provider. And here's basically our application. It actually gets some data from external system. And you can see that there are some sources. So here we actually using production implementation. So if you go to Hacker News, I think we will have these stories on the top. Oh, yes, here, for example. A brand new 864K Mac emulator dropped last night. So basically here in this application, you can see that basically we queried these stories and we retrieved the information. So all is good. And we have a real production, a real production implementation that serves the data. And then we can actually switch to mock implementation if needed. So how to do that? Actually, it's just another command that would be need to provision. Let me show it. Okay, just a second. Okay. So you still see my browser, right? Mm-hmm. Okay. Mm, yeah. Oh, let me just change the screens again. So yeah, we have this C line, but in order to actually test something, we can provision a test implementation so that it will leverage our test environment. So it's git test run. It's another command that basically takes another environment. And here you can see that the behavior, the startup behavior is a little bit different. So here it wasn't just a test container stuff that was promoted, but here you can see that there is a whole bunch of things defined in the stack traces. So we can see that basically DevTools detected our configuration that we would be using something, and then it loads Docker Compose with the model and initializes test containers to actually provision this image and connect to it. So we have test containers starting, then basically there is a lot of code, but finally we get basically to test containers and WireMock starting specifically for this application. And now if you go to our database and to our service, it will be more or less the same as before, but we actually connected transparently to the service that is provided by test containers and WireMock. So where it is. Oh, yeah. So let's refresh our page. So this is our service. But if I ask what's up on Hacker News now, yeah, so it basically went to query the data. Why don't I have permission? Okay. Um, So yeah, we'll just connect terminal. So hopefully it's not too wide for you. It now should be showing two screens in parallel. So what happened? I actually queried, refreshed the page, and basically this page started execution. You can see that there is some strange looking things here. So for example, there are queries going somewhere because we also have an AI part for summarization. And after it was executed, you can see that there is another set of data that is being retrieved by the same application. So the only thing we did, we launched in a different configuration, but everything is a little bit different. Why it happens? Again, let me open my IDE, and then I definitely don't want a third screen. So yeah, let's just do like that. So in this application, you can see that there is some on-demand provisioning, and this on-demand provisioning, yeah, we have some AI part. If you want, I can show it later. But the main part is basically this stuff. This is which is provisioned by WireMock and this and it's Testcontainers model. So basically, it provides on-demand requests and responses depending on the configuration. And what we did with the test run, we just said that for this configuration, we actually need to be provisioned by WireMock, and we started leverage this configuration file and the WireMock service instead of full application. So in Spring Boot, this is all you can do. You provision a service that mocks it. In Quarkus, for example, you can have live reload, so you can update this file. It will be providing different responses from our service, and we can do parallel development by injecting additional data or additional data structures so that we can co-develop our application and our service provider. So this is how it can work in principle. There is a lot of code which is specific to the framework. I'm not sure whether you want to see it, but if so, let me know. So what we basically did here, we started local developer environment using the same tools as we used before for integration tests. And yeah, it's still quite handy. Okay. So if you have any questions, just ask or put them in the chat. It's actually my first ever experience of a giving workshop in Zoom remotely, so as you can notice. So yeah, if there are any questions, feedback, just go ahead and ask them. Meanwhile, so what we did from our part, if you follow along, we basically built this project, this project, this project, and these projects work quite well. So it's just samples of integration tests that you can reuse for different purposes. And the part that I haven't touched yet completely is actually deployment side. So deployment is Pulumi, and from what I heard in the beginning, there are people who are using Pulumi on this call, but just a quick refresher. So you can use YAML files and definitions, of course. Well, sometimes it's a little bit difficult to maintain if you use Kubernetes. There is a lot of Helm charts, and yeah, it's basically difficult to control and very difficult to test because you need to generate custom files. It takes quite a lot of time to verify the configurations and then to ensure that the systems work. Still, you can do it. So, for example, for native Kubernetes applications, if you use Testcontainers, you don't even have to provision your own cluster because, for example, there is K3s model, for example, at least there was, which basically provisions a simple Kubernetes cluster that is also available Golang, Python, Node.js. And once you provision this container, again, you can just have your Kubernetes cluster running. It works really well for self-deployments. So for example, if you use whatever Kubernetes cluster on Amazon, on GCP, or just do self-hosted, you can use these models to actually verify your whole deployment. And if needed, you can even deploy, for example, Argo CD in the same container to do testing of the whole deployment pipeline. But if you talk about services like AWS, of course, it's not always as easy as that, because yeah, not everyone uses well, not everyone uses Argo CD, not everyone uses Kubernetes, and you can still and you still will have maybe another 500 or 600 services provided by AWS that cannot be easily put in test containers in Kubernetes or in other model. And for that, you can actually deploy test against the local implementation. One of the tools for that is quite popular is actually Localstack, which we touched. And Localstack can be tested with the same tools as we are discussing. And if you want to do the same deployments in Java, there is Pulumi. So what we will be using for now is firstly Localstack. So it's basically, again, a framework that mocks your tools, in particular AWS services. And Pulumi is a deployment tool. So Pulumi basically, well, it's a service too. Let me check whether I still have account on Pulumi. I'm not 100% sure. But yeah. Okay. So yeah, you can see that I actually have quite a few applications, and yeah, there is mocks as code demo. So basically, Pulumi is needed. Pulumi service is needed even for the local deployments. Pulumi was designed as a service that does deployments online. So it's a service that you can reuse to deploy applications to different public clouds, including AWS, of course. And if you want to test Pulumi deployments, there is a project called Pulumi Local. Actually, there are multiple projects called Pulumi Local, which might confuse you. So the first one is actually Pulumi Local that is on Pulumi side. So this is not what you need to use to do some integration testing for your pipelines with this tool. And there is Pulumi Local, which is on Localstack. So this is what you would normally do if you do integration testing for Localstack. The idea is quite simple. Pulumi has a bunch of various ports. Pulumi talks to AWS endpoints and then has a lot of services. So to teach Pulumi to talk to Localstack for integration testing of your pipeline, you need to do quite a lot of configuration. And Pulumi Local is basically a script that basically does all the injection. Yeah, it is. Oh yeah, you can see that basically it's a lot of configuration going there. And the idea that once you have Localstack deployed on your machine, you can use you can override Pulumi configuration, etc., to connect to the service. It works quite well, for example, if you do testing with external deployment. But what if you do integration tests? So in our case, we have Java, we have tests that we've written in Java, like basically I presented, and we would like to test Pulumi, I think, also in the same framework. And it actually it makes a lot of sense because, yeah, Pulumi is deployment as code, so it has Java implementation as SDK, so you can write the whole pipeline, deployment pipeline in Java. And in our application, we can actually do the same with help of the tools. So let me show the IDE. Okay. So I will show how Pulumi projects look like. So again, it's a simple project for aspiration. So this project basically provisions an S3 bucket, which basically can be used. And here, okay, it's very simple. It just has some configuration, some initial value in the bucket, and you can see that the code actually becomes really quickly. So for example, here, if you want to create a bucket on AWS, you still need a policy. And if you do it from the web interface, you might remember how many controls it has. Here, what we can do, we can actually change the configuration and try to do it locally. So for doing locally, one of the things that you can always do is just create Pulumi YAML file and configuration. So this is basically what gets created by Pulumi by default. So if you start developing, if you log in, you can have basically, well, you can have some configuration, you have target region templates, and you can see Java Gradle. So Java Gradle basically allows Pulumi to take the code and to execute basically this piece of, this piece of code. So it has all automatic building and binding. But if you want to test, none of that will work because tests need to be written in a bash or whatever test scripts if you want to use CLIs. But you can actually do some binding to do it in Java. So it's rather aspirational. So you can create basically your own adapter that is more functional. In my case, I just created it for the demo purpose. So you can see that there is basically some configuration script that again goes to your directory and generates the configuration that would be usable for local stack. So here, Pulumi stack YAML, it basically does some configuration, initialization, and then when you actually run, you can trigger a Pulumi execution with all this configuration so that it can return the necessary results. And then after you have this implementation, the test can look like that. So it's a test that actually does local deployment. We will try it in a few minutes. And here you can see that basically in our test, we firstly initialize local stack. And you can see that again, we use Testcontainers and the local stack. So we don't provision anything locally. And we configure the service. So here, for example, we say that yeah, we will still have random queue name. We also configure a Pulumi local stack adapter. So the idea is that it overrides CLI configuration so that the test when it runs, it's actually compatible. And then, yeah, there is local stack execution that basically starts local stack inside the container and again creates SQS that will be compliant with our requirements. We also do some configuration like in previous demos. And then all the test for this particular case is basically ensuring that this thing can actually start up. So let's take a look whether it can start up. I bet it won't. So let's see. Okay. So you can see that despite all the hopes or no hopes, it didn't start. And we can just check what happens. So here you can see that we basically try to go to initialize the thing. And then when we run in Pulumi, we can see that there is no even stack provisioned. But I suspect that it actually happens because we are not even logged in Pulumi here. So I don't think it's very relevant. Of course, to troubleshoot it, we can still use Gradle tools. So for example, I can just get report. Well, the report isn't particularly helpful. It's just a unit test in this regards, but at least it points us to proper location. And yeah, so basically, long story short, CLI didn't even start. So let's try to follow the documentation. I'm not sure whether it's a good idea or not in this case, but let's see. So what we are recommended to do in the test is that we just have Pulumi stacks select. I'm pretty sure that the real issue is that I didn't log in the service. So okay, yeah. Okay, now I logged in, so we can actually configure our environment and get it running. Let me just again show the screen. It's not designed for many screens for sure. Okay, So here, basically, I logged in, and now I can select proper stack. So here, for example, Mox as code demo is the stack I'm using for this configuration. And this is the stack that is actually being generated on demand. So let me show it again. What is okay, so if you switch to IDE, now you can see that basically we have Pulumi, Mox as code demo YAML, and this is the file that is being generated automatically for the test. And you can see that there is no magic here. We will be using local stack. So every time we launch, we map the ports to different locations. It's basically what Testcontainers and WireMock do. And we just replace this part with proper ports. And it's quite easy in this setup. Everything just goes to the same containers, to the same ports. So everything else is handled by API. And you can see that this tool does best effort to actually map all Amazon services. So yeah, there is quite a lot of them. Let's see what happens now with the deployment, whether Pulumi can actually run in this configuration yet. It cannot. Okay, maybe it can. You can see that it started and it actually sends us to Pulumi because Pulumi is a service. So our integration test cannot mock Pulumi yet. If somebody wants to do it with a WireMock or test containers to have local emulations, it would be interesting experiment, but now it goes to the service and we can actually go to the service and see whether it actually deploys the thing. So while I was talking, you can see that it actually did the proper deployment, and this deployment goes to local stack. So in local stack, we got our instance of an AWS service that is provisioned, that has all the necessary configuration, and we also tested the deployment pipeline for our service. So this deployment pipeline was really simple. So it's not what you would do in production application, but depending on your configuration, depending on your deployment. For example, if you want to deploy one of the applications we discussed, you just build it, you have jar files, etc., and you can basically provision it whatever Java hosting service provided by Amazon. Or you can build your own Docker image and deploy it. Obviously, if you use EC2, etc., it's quite complicated. If you use Kubernetes, etc., it becomes easier. But in this case, probably you don't even need a local stack. But for combined solutions, yes, you will need to combine the approaches I presented here. So basically provisioning a local deployment pipeline that connects to local stack and test containers. And you can combine it with the application deployment pipeline so that, for example, you can configure AWS here. It just takes long, so it doesn't make any sense to use it in integration testing right now. But for deployment testing, for one-time operations, you can actually use this pipeline as an example to provision these services. So any questions? Okay, let's take a look at what actually happened in the UI while I was talking. Yeah, so this is basically what Pulumi demonstrated. So yeah, it's not an integration test you want because it still uses external deployment unless you have an enterprise version with self-hosted Pulumi. I don't have it. And yeah, you can see that basically it's deployment, it's execution, and yeah, you can see basically the configuration that we had, like for example, bucket policy, etc. All of that got provisioned, but all of that got provisioned to local stack. So no real AWS was used. Okay. So this is what I wanted to show. Again, there is a lot of other things that can be done if you use the infrastructure as code. Again, Pulumi is available for most of the technology stacks we touched. And this service actually supports other platforms. So it's not just AWS, but yeah, I've tested only with the AWS, but for other tools, there are also SDKs available. And of course, there are different extensions. So what I presented is just for three, but if you want a more advanced deployments, you can see that there is also quite a lot of configurations available in Pulumi that again provide SDKs for particular services. And you can see that there is, for example, Sivo available, so you can deploy to Sivo public cloud too, or directly to Databricks if needed. Or I definitely saw Exascale somewhere. Yeah, Exascale is a European cloud provider, quite popular in Switzerland. So you can see that there is a lot of things you can get for deployment, and basically for all the things you can get inspired for pipeline testing. It takes time. You can set it up, and yeah, it becomes quite handy once it runs. So basically, this part, yeah, I haven't really presented the deployment tests yet because again, we just ensured that the system is deployed. But you can combine both approaches and do them in longer workshops. So this is actually one of exercises, and yeah, Pulumi and Localstack is what you can reuse. Okay, if you want to know more about examples and configurations, at some point we actually created a page that basically demonstrates how to use it, and you can see that Anka created quite a lot of additional configurations and demos that go beyond what I presented. So this, for example, for Spring Boot, it's one of the applications we use, and here you can see that there are more advanced configurations that you can try out. And yeah, again, there is a test that you can run, for example, if you want to see how to do deployment tests. So again, nothing really surprising here. So you just have a configuration, again, Testcontainers that has all the mapping, local stack, and then basically it does all the stuff with Pulumi adapter. You can see that basically it also has manual tear down because it's needed to source the allocation. And then there is a test that basically sends, again, hello, like we did in the initial demo. And then it waits for the message to appear to S3 and to show up. So this is basically a deployment test that one would normally use for local stack with Pulumi deployment, etc. This is what you can do. Another part that I didn't really talk today is this one, production health checks. Again, most likely you use a monitoring system that already does all the checks, whether you use OpenTelemetry, whether you use other frameworks like, for example, Checkly. I mentioned Checkly specifically because it allows writing tests in different frameworks, including Node.js. But you can also connect them to this system if you want, but it's even more complicated than Pulumi, so it requires more hacking, more configurations, and this is not what I normally do. And what you will definitely hit when going, for example, later through this demo or when using another demo is troubleshooting. So, of course, as we use Gradle, there is quite a lot of tools just embedded which you can use. I briefly mentioned the problems report. I presented visualizations, but what I want to say that all of that is actually available for tests and deployments too. So, for example, in this execution, where we are. So, for example, if you want to build the whole project from the repository, I'm pretty sure that something will break. Let's see. Or maybe it will work now because we have Pulumi in the environment, so we can see. So here we don't see anything because again I didn't share the proper window. Okay, so here you can see that basically I launched the build for the whole project. So all models that we touched today, you can see that some bits already failed. Like for example, there is AI service that is supposed to do the mapping. So I disabled my local model that I was using for summarization. So this test failed, and there are other test fails. So yeah, what you can do in this case, of course, you can always troubleshoot things. I won't impress you by JUnit report, of course, because it's, well, a common tool. But what you can also consider using for more production use cases here is actually the velocity report. So we published bill scans for troubleshooting. And here you can investigate a lot for tests, especially when you depend on environments like Testcontainers, Localstack. Sometimes things still fail. And here you can basically use this tool. Well, if you use the velocity commercial version, trends, flaky test detection, but here you can at least troubleshoot what went wrong and analyze the bits that I missed. I'm again not screen sharing, right? Sorry, it went well during the hardware check, but right now I just cannot share the whole screen due to reasons unknown. Yeah, so where I wanted to go? Yeah, to Google Chrome. Yeah. So basically, when you submit a test, you get a lot of information here, including the execution timeline, caching things, and specifically for this, for infrastructure testing, etc., you will be able to see the whole test execution. So here, for example, we can see that some tests failed, the ones that actually load the stories, because here you can see that there is some AI missing. Well, you can see that connection to something refused, and this something is actually, well, AI endpoint, I believe. So this is what you can use for very basic analysis and integration tests. We are running out of time. I think we still want to have a few minutes for questions if you want. I'm not sure, but yeah, if you want to find all the information, again, we have GitHub repository. You can just rebuild every project from there. We also have basically the demo. We have this slide deck that is will be deployed just after this presentation. And yeah, my recommendation for you, just keep learning tools, trying them. This basically was a really quick glance in Testcontainers, WireMock, and other tools that you can use for AWS testing. And yeah, keep exploring tools. And of course, everything I presented today is open source, except the velocity part, and all the contributions are always welcome, as well as feedback. Any questions? Do you have comments? Do you want to clarify some bits, especially for those who haven't touched these tools before? Okay, so then all the materials are there. If you need any particular information, we have Testcontainers Slack, WireMock Slack, Gradle community Slack with all kinds of developer productivity, engineering, and integration testing. So happy to chat then, and thanks a lot for your time. So I see that we had 5 downloads for this project, so somebody at least started the demo. And if you experience any issues, again, ping me. I'm happy to provide some support and address any questions.